Welcome dear student. Today we will learn the basic concept part in which we will know about the electronic configuration of an atom. So before going to electronic configuration, first we will know about the subatomic particles and their location in an atom. I have already told that an atom is spherical in shape and it contains nucleus at its center, and nucleus bears or possess one part out of the 10,000 parts of an atom. So, excluding this one part out of the 10,000 part of an atom, the rest part of an atom is called as extranuclear space. This space, it is the nuclear space. This space is called as nuclear space. It is called as nuclear space, and the rest, all these parts are called as extranuclear space. Extranuclear space. Extranuclear space. Extranuclear space. So this extranuclear space mainly possesses electrons, and I have already told nuclear space contains proton and neutron. Okay, we will know detail about extranuclear space, and next we will move to the electronic configuration. So our main motto is to learn electronic configuration. Now what is extranuclear space? Extranuclear space. So extranuclear space, we can define it as the vacant space or the space of an atom which is mainly for electrons, or the part excluding the nuclear part. So it mainly includes three different parts. That means it includes cells or orbits, subcell or orbital, and final one is suborbital. So these three spaces comes under extranuclear space. Now, where these concepts come? These concepts come from the quantum number concept. So what is a quantum number? I am relating the concepts together to make you understand the electronic configuration. So quantum number is the identification of electron, or the address of electron in an atom is called as quantum number. It is of four types. That means principal quantum number, I am writing in shortcut, that is QN, principal quantum number, and the next quantum number is azimuthal quantum number, third one is magnetic quantum number, and the last one is spin quantum number. Fourth one is spin quantum number. spin quantum number. So the principle, as the name says principle, it is the vital part of the quantum number concept. That means it expresses the larger space for electron. That means it expresses about the cell. So I have written in front of the cell. And the azimuthal quantum number expresses about the subcell, that means orbital. It is the space below the cells, so it is called as subcell. And the next part means the suborbital space comes under the orbital, that means the middle space. It is the smaller space which possesses the electrons. And the last spin quantum number expresses the direction of rotation of electron in an atom. Next, the principal quantum number is always expressed by the symbol small n. So the cell is expressed by the symbol small n. The subcells are expressed by azimuthal quantum number, so whose symbol is L, small l. And the suborbitals are expressed by the magnetic quantum number, whose symbol comes as small m. And the direction of electron in an atom, I have already told, is represented by the spin quantum number, which is expressed by the symbol small s. So we can remember the sports, that is musical chair, in which the last two contestants show clockwise rotation and anti-clockwise rotation. Such type of movement is expressed by spin quantum number. That means electrons in an suborbital, shows clockwise, either clockwise movement, and another electron shows anti-clockwise movement. We will later know in detail about the quantum number. I am telling that part of the quantum number which is related to understand the cell, subcell and suborbital concept. So the symbols, from the symbol and the quantum number concept, small concept of the quantum number, we will learn about the detailing about the cell, subcell and suborbital. Okay, I am wiping the parts of quantum number, and we will learn the next parts of the quantum number in the coming classes. Okay, so say n express the cell, that means n express the serial number of the cell. Serial number of cell is expressed by the symbol n. So everyone know that serial number always starts from 1 and then it ends with infinity. So the starting n value is 1, and the next 2 and 3, 4, this is. Okay, the value of n always express the name of cell or orbit, name of orbit. So the cell or orbit whose n value is 1 is called as K cell. The cell or orbit whose n value is 2 is L cell. Similarly, the n value 3 expresses the M cell and the n value 4 expresses the N cell. So after knowing the name of the cell from the n value, we learn how much electron can be carried out by these orbits. So for this, we have to know the 2n square rule. 2n square rule for maximum electron. Maximum electron in an orbit. So maximum electron is calculated by 2n square rule. That means K cell can occupy 1 square into 2, that means 2 electrons. 2 square into 2 equal to 8 electrons. M cell can occupy 18 electrons according to 2n square rule. and 32 number of electrons can be present in an orbit according to 2n square rule. So moving forward to subcell, so I am making a box to compare the chart for better understanding. So as the name shows, subcell, it comes under cell. So the L value that expresses subcell depends upon or derived from the n value. That means the formula L equal to n minus of 1 will give you the idea about the subcell. So from the L value we can know in detail about the subcell. So starting L value will be n minus of 1 and starting N value is 1. So 1 minus of 1 will be 0. So starting L value is 0. Okay, the second L value will be, second N value is 2 and the 2 minus 1 which will give the second L value, that means 1. And third L value will be 2 and the fourth L value will be 3. From this value I am subtracting 1 to get the L value. Okay, next from here we know that the n value expresses the name of the cell or orbit. Similarly, the L value will express the name of subcell or orbital. So next one is name of orbital. Name of orbital is 0 L value express the orbital, that is S, and the L value 1 express the orbital P. Similarly, the L value 2 express the orbital D, and the L value 3 express the F orbital. From the name, we know the maximum number of maximum electrons which can be filled in a cell. Similarly, maximum electrons in orbital can be calculated by using the 4L plus 2 rule. So maximum electrons in orbital by 4L plus 2 rule. 4L plus 2 rule. That means S can occupy 4 into 0 in plus 2, that is 2 electrons. Similarly, P can occupy 6 electrons, D can occupy 10 electrons, and F can occupy 14 electrons. From this, we can know there is 4 gap. It is not the concept, it is the trick. But the rule is 4L plus 2. Okay. You should know the rules and can remember it through tricks. Now, the final one is suborbital. So the total, I am telling about the total number of suborbitals. That means I am not explaining in detail about the suborbital name, but only telling that how many number of suborbital is coming under the 4 different orbitals. So only this part I will tell, and I will tell in detail about the names in the quantum number concept. So now the m value depends upon the L value. As L comes under N, so it is L value calculated from N. So M as comes under L, so M value can be calculated from L value. That means M equal to minus L value to plus L value through 0. Minus L value to plus L value through 0. So now different values. So 0, and starting L value is 0. So 0, there is no effect of plus minus in the 0 value. So the s orbital has no suborbital, means the orbital is itself the suborbital. Single. Okay. There are 3 m values, that means -1, 0 and +1, the 3 m values for the p suborbital, p orbital. So it has 3 suborbitals. So I am writing the total number of suborbitals present in an orbital. So d orbital similarly has 5 suborbitals, and f orbital has 7 suborbitals. We calculated this total number of suborbitals from the total number of m values. Now we should know how much number of electron can be filled in each suborbital of the orbital. So we can use our logic. That means each in f orbital 14 electrons are present and it has 7 suborbitals. Each suborbital is expressed by square bracket. That means there are 7 square brackets. So each square bracket will occupy 14 by 7. That means 2 electrons. 2 electrons. Similarly, you can know 10 electrons are there, 5 suborbitals are there. So each suborbital will occupy 2 electrons. 6 electrons are there, 3 suborbitals are there in p orbital. So each suborbital will possess 2 electrons. I have already told in spin quantum number, each electron pair move one in clockwise manner and another is anti-clockwise manner. We will know in detail about this concept in the quantum number concept theory. Okay, next our motto is to learn electronic configuration. So from this small concept we can know about the electronic configuration. So the next part is electronic configuration. Electronic configuration. So configuration meaning arrangement. Configuration meaning arrangement. Electronic related to electron. The arrangement of electron in different orbitals and suborbitals according to the increasing order of energy is called as electronic configuration. This concept is derived from atomic structure chapter and based upon Abbo's principle. Abbo is a Greek word which represents arrangement. That means I have already told arrangement of electron in various orbitals and the suborbitals coming under that according to the increasing order of energy. So before going to this concept, small concept, that is calculation of energy, we should know the energy of orbital, energy of any orbital, energy of any orbital equal to given n value, n value is given in LHS side, left hand side, plus of fixed L value, That means, let's understand it with an example. Let's take 4f orbital, 3d orbital, 4p orbital. We'll calculate the energies. Before going to energy calculation, you should know the fixed L values. That means name of orbital L value. We have already learned about that part. That means S orbital has the L value that is 0. P orbital has the L value that is 1. D orbital has the L value that is 2. F orbital has the L value that is 3. So they are the fixed L values which will be used in the fixed L value section of the orbitals. The n value, these whole numbers express the n value. So energy of 4f orbital will be 4 plus of given LHS side, 4 is given in the LHS side 4, and f has the L value that is 3, 4 plus 3 is 7. So in 3D the energy will be 3 plus of D has the L value 2, so energy will be 5. So that means 4 plus of P has the L value that is 1, that is 5. So if we will arrange this 3 orbital according to the Auerbach's principle, then the electron configuration order will be the mark. Here two energies are equal. I have told orbitals are arranged in the increasing order of energy. So here energy is 5, 7. So 5 will come first and then 7 will come. But if the energy will be same, so what will be the condition for choosing the correct one or the first one? So if the energy of the different orbitals gets similar, then the orbital with lower n value, n value will be arranged first, that means it will come first, and then the orbital with same amount of energy but higher in value will come in second, and the last one will be the maximum energy carrying orbital, that means the 4f orbital. So we got the idea about the arrangement of orbital according to the increasing order of energy. Okay, so we will come in detail about the electron configuration from the complete data, the complete concept. As we know, the n value of s orbital is starting n value is 1. So I am writing 2s, 3s, 4s, up to 4s I am writing, and the n value of p orbital is 2. So it is 2p. There is no 1p because the starting n value is fixed and the ending n value is infinity. And 3p, 4p. Lower values are present but higher value is not present as the starting n values are fixed. In case of D, there is no 2D, no 1D because the starting n value is 3. So 4D. And similarly, the F has the n value of 4. Starting n value is 4. So according to the rule I have told, the orbitals with lower energy value will come first and the higher energy value orbital will come later. So the starting energy, the 1s is 1, and the starting energy value of 2s is 2, 2 plus of 0, that is 2, and the energy value of 2p, that means L value of p is 1. I have already told the energy of the total 2p orbital will be 3. Similarly, the energy of the 3s will be 3 and the 3p will be 4 and the 3d will be 5. In this concept, we can calculate the energy of 4s is 4 and the energy of 4p is 5 and the 4d is 6, 4f is 7. So you can know there is C3 energy is equalizing. The energy of different orbitals gets similar. I have told the concept that if the energy gets similar, then the orbital with lower n value comes first and then the higher n value. If it is coming 4, 4, then the 4 can become the 4 can be here the 3D and 4s orbital has the n value 3p has the envelope 3d, 3p has the 3d has the envelope 3 and the energy is 5. So 3p and 4s, 3p as the energy value is 4 and 4s as the energy value 4. So I am taking you till 4 because the 5s has the energy 5. So if we will go for 6, then we can skip the 5s orbital. So I am not going for 5, I am remaining till 4 energy level. So to have the correct sequence of these orbitals, I am writing that energy with lower orbital with lower energy level is 1s. So starting orbital is 1s, and the second one is 2s as energy is low. So the second orbital is 2s. It is the proper sequence of the orbitals for the electronic configuration. The next is 2p. 2p has the 2p has the energy of 3 and 3s has energy 3. Due to lower value, it comes first. Then is 2p, and the next one is 3s. And after 3, we are going for 4. That means 3p and 4 is 4s. So we can go for 5, but I am not going for that. So 3d will be 5, 4p will be 5, and 5s will be 5. If you are going for 5, then consider the next one, that is 5. So it is going downward. So consider the down part which are not written here. So before selecting the proper sequence, have the idea of next part to avoid the mistakes. So we'll learn about the next parts of the electronic configuration in the coming class. Thank you. If you have any doubt, comment in the comment section, and if you want more videos on any concept, comment on the comment box. I will make short videos on your demand. Thank you.